let's say that there's a hill kind of like this, and a soccer ball is kicked up at an initial velocity of 10 meters per second at an angle of 30 degrees. And we have Dash here from The Incredibles, who needs to know, who's going to start running after the ball has been kicked in the air, but needs to know how far to go in order to get there right as the ball touches the ground. So this is the projectile and this is the hill. And from the demo that we learned in class, we know that we can kind of like draw a perpendicular line here and draw it as a normal kind of flat projectile. So if we have the ball going like this and Dash needing to know the distance that it takes to get from here to here so he can run that distance in order to intercept the ball, that's equivalent to finding the range. So we're going to find that range by looking at the right triangle that this creates. So we have this right angle and an initial speed of 20 meters per second. Now if this is a 30-degree angle, then we know that this is a 60-degree angle, and our 30, 60, 90 right triangle states that this side is going to be 10 meters per second, and this side is going to be 10 root 3 meters per second. So in order to find the total time in the air, we do this really easy thing for our vertical speed, or velocity, in which we take that 10 meters per second and divide it by 5, and that gives us 2 seconds in the air because of the entire 1/2 AT squared equation. Now that we have the total time in the air, we're going to look at our horizontal direction, which is given by the equation x equals v times t, because you got to keep them separated. And so we're trying to find x, or the range, when we have our velocity of 10 root 3 meters per second times 2 seconds, which is, the seconds are going to cancel out, and we're going to get 20 root 3 meters as the overall range, or the distance that after the ball is kicked, Dash will have to run in order to get to where the ball meets the ground.